The last thing that we're going to look at in this section is the domain of a function. When we're asked to find the domain of a function, it is helpful to remember that essentially there are three cases. First, you can be given a problem that contains a fraction. Second, you could be given a problem that contains a radical. In most cases, this will be a square root. And then third, we're going to lump everything else into this third category. These are essentially the problems that do not have a fraction and do not have a radical. So let's begin with a couple of examples for fractions for case 1. If our problem has a fraction, we need to be concerned about the x value that would cause the denominator to equal 0. To find the domain, we want to exclude any number that causes the denominator to equal 0. For example, on our first function, x divided by x minus 1, consider what would happen if the x value was 1. So if x was 1, then you would plug in a 1 on the top and a 1 minus 1 on the bottom, which would give you 1 divided by 0, which we're not allowed to have. So when you write your domain, what you want to say to yourself is that every x value is fine except the positive 1. Because if positive 1 goes into that function, you're going to end up with something that's undefined. You're going to end up with that 0 in the denominator. So when I write my domain, I have a couple of different choices for how to write that. I can say that my domain is all x values except x is equal to 1. You can also write it in set notation, which means that you write it like this. You say x, all x, such that x does not equal 1. You can also write your answer in interval notation, which means that you're going to set up intervals and you're going to exclude the 1. So you would have an interval that started at negative infinity and ran all the way to 1, and then it's going to break at that point and pick back up on the other side of 1 and go to infinity. And we're choosing to use parentheses next to the 1 to indicate that the 1 is not included in the answer set. When you look at your second example, x plus 5 divided by x squared minus x minus 12, you want to realize that this quadratic equation in the denominator of the fraction will factor. So we know that we'll need an x in both of the first positions. To make the negative 12, we'll need a 4 and a 3. And to give a middle term of negative 1, we'll need the 4 to be negative and the 3 to be positive. So once it's factored, you should be able to tell that potentially the problems are going to be a positive 4 or a negative 3. A positive 4 will cause the first parenthesis, the x minus 4, to become 0. A negative 3 will cause the second parenthesis, the x plus 3, to become 0. In either case, you're going to end up having an undefined function if you allow those values to be plugged into the denominator of that fraction. So what I want to say here is that my domain is going to be all x values except x equals 4 and x equals negative 3. Again, if you'd rather write it in set notation, you're going to do a bracket and you're going to say all x such that x does not equal 4 and x does not equal negative 3. Or if you want to write intervals, you're going to write, it'll take 3 intervals this time. We're going to go negative infinity to negative 3. Then picking back up on the other side of negative 3, we'll go to 4. And then picking up on the other side of 4, we'll go to 4 to infinity. And we're going to put u's in between both of those. So again, remember that if you have a fraction, your answer is going to be everything but the number that makes the denominator equal to 0. Case 2 are radical problems, which again means in most of our cases, it is going to mean that we're talking about a square root in the problem. Our hint says that we want to be sure that what is under the radical stays positive. And the reason why is because we cannot take the square root of a negative number. Okay? So what I'm going to do to determine my domain is I'm going to take what's underneath the radical. So for the first example, 3x minus 12. And I want to be sure that it stays positive. So I'm going to set it greater than 0 because we know that positive numbers are greater than 0. Now, it is possible to have a 0 underneath a radical. You can take the square root of 0. So we can take the square root of positive numbers. We can take the square root of 0. But we cannot take the square root of negative numbers. And so because we've already got the positive case here, but this also can equal 0, I'm going to put an equal to underneath. And then we're simply going to solve this expression. All right, so I'm going to begin by adding 12 to both sides of the inequality. So that's going to give me 3x is greater than or equal to 12. And then I'm going to divide both sides by 3. And so my domain is going to be the x values that are greater than or equal to 4. And again, if you want to write set builder notation, you're going to say all x such that x is greater than or equal to 4. If you want to write interval notation, you're going to start with 4, and you're going to go all the way to infinity. Now, because that 4 is actually included as part of the answer set, I'm going to need to use a bracket on the 4. Our next example has both a fraction in it and a radical. So let's look at how we're going to approach this. First of all, in terms of the radical, remember that the radical has to stay positive. So I'm going to take what's underneath the square root, and I'm going to set it greater than or equal to 0. So that is always going to be my approach if I have a square root. Take what's underneath, remind yourself that it has to stay positive, and make an inequality greater than or equal to 0. And so when we solve that inequality, I'm going to add 9 to both sides. And so I'm going to get x is greater than or equal to 9. Now, the only problem with this is that now we need to think about the fraction. Remember that for the fraction, you cannot have the denominator of the fraction equaling 0. So what is the value that would cause the denominator to equal 0? Yes, so if x is equal to 9, the denominator is going to be 0, and we're going to have a problem. So I think instead of saying greater than or equal to 9, let's take the equal to off, and let's just make it greater than 9. Because if it's equal to 9, we're going to have undefined because we have the 0 in the denominator of the fraction. So you have to consider both things. You have to consider how to keep it positive for the square root, and then you have to be sure that what you're coming up with for your answer does not cause a 0 in the denominator of the fraction. All right, so my domain is going to be the x values that are greater than 9. Set builder notation would say x, such that x is greater than 9. Interval notation would start with 9 with a parenthesis and go to infinity. And then case 3. Case 3 is everything else, and by everything else I mean problems that do not have a radical and do not have a fraction. Domain for these functions is always going to be all real numbers. So if you look at 5x squared plus 2, you say to yourself there's no fraction, there is no square root, so the domain is all real numbers, and you can write that like this, negative infinity to positive infinity, or you can simply say all real numbers. For our second problem, 3x plus 4, again, we do not have a fraction and we do not have a square root, and so our domain would be all real numbers. We would run from negative to positive infinity. So these 3 examples that we've just looked at, or these 3 cases that we've just looked at, deal with problems where they're giving us an equation and asking us for the domain. The other way that this can be presented to us is they can give us a graph and they can ask us for the domain, and for the graphs they will also be asking you for the range. So I want to run through a couple of examples of this with you. Remembering that the domain is the set of x values. And remembering that the x-axis goes left to right. And so the question you should be asking yourself for the domain is how far to the left does the graph go and how far to the right does the graph go? So to the left, this is my leftmost point right here on the graph. And that point has an x value, because remember that we're talking only about the x's right now. That value, that point has an x value of -5. So my domain is going to start with -5. Now I need to find my rightmost point. My rightmost point is not noted on the graph because we have an actual arrow at the bottom here. That arrow indicates that the graph is continuing down, but also to the right. You can see that the line is gradually moving to the right as we go further down. So how far to the right does this line eventually go? Well, if it never stops, then eventually it's going to go to infinity. So we're going to say our domain starts at -5, including that point, and runs to infinity. Remember again, the domain is how far to the left and how far to the right does the graph stretch. Now the range is the opposite of that. The range is your y values. And so you're looking at how high up and how far down the graph stretches. So find your lowest point on the graph. And again, you can't actually touch the lowest point because the lowest point is indicated with this arrow. So how low does the graph go? It goes all the way to -infinity. Now find your highest point on the graph. Your highest point on the graph has a y value of 5. And since 5 is included, we're going to place a bracket by the 5. So again, domain is going to run left to right. Range is going to run up and down. Okay, let's try it one more time. Find the domain and range of the graph. All right, so domain goes left to right on the x's. So we find our leftmost point on the graph. Which would be this point. And we ask ourselves, what is the x value that goes with that point? So that x value is going to be -2. Now, if you notice on the graph, they have that open circle, which means that the graph doesn't actually have a point at -2. It just gets very close. So we'll use a parenthesis when we write our domain. Now, how far to the right does the graph go? This is my furthest right point. And where is it? If I drop down, I can see that I'm at +2. Because that has a closed circle, I'm going to use a bracket. That's my domain, left to right. For my range, we'll start with the lowest point and then go to the highest point. So my lowest points are here and here. And those points are down at -5. Now let's look at our highest points. My highest points are up at 4. Because one of the points does have the closed circle, we'll go ahead and use the bracket on the 4. So our range runs from -4 or -5 to +4, and our domain runs from -2 to +2.